Hi everyone, welcome to this last video where we talk about domain and range of functions. So in the previous video, we saw some examples on how to find domain and range. So in this video, I'm going to talk mostly about how to find domains of some functions, and in the next video, we'll just use the idea of inverse functions. We'll show how to find inverse functions for some simple cases. And in the last video, I plan to talk about plotting functions, their graphs with logarithmic functions and exponential functions. Just some introduction of it because we're going to need them in our study of calculus. So without further ado, let's start. We start with an example where we want to find the domain first. So let's say there is a function f of x, which is equals to square root over x minus 3 divided by x plus 2. We want to ask what is the domain of this function. All right. For now, let's not worry about the range. Our primary target is to just solve for the domain of this function. So as you can see, we have a fraction and a square root. So let's break down all these facts and do things step by step and see where we can get. All right, so I'll just switch to the fountain pen because I think that's pretty neat. All right. So first of all, since this is a fraction, you can easily see that x plus 2 cannot be 0. That implies x is not equals to negative 2. Now, we have dealt with the fraction part. Now we have to deal with the square root part. The square root dictates the fact that this fraction, that is x minus 3 by x plus 2, cannot be negative, right? Because we are dealing with functions that take real numbers as input and spits out real numbers. So that's why we argue that the number inside the square root is not negative. So one might think, okay, I'll just do x minus 3 divided by x plus 2 greater or equals to 0. And that should give me x greater or equals to 3, right? However, that is not the case. That is not the case over here. Why? Let's see. We have two numbers, one in the numerator and the other one in the denominator, right? However, let's take a example case. Let's say x equals to negative 5. That brings us to the point where we have a negative 8 in the numerator and negative 3 in the denominator. This negatives cancels out and you have something positive inside the square root. So obviously this condition is not enough. It doesn't tell you enough about the domain of the function or how to deal with the fraction that is inside the square root. So what do? Now we demand the fact that this fraction over here, the numerator and the denominator, will come in terms in such a way such that the ratio itself is positive. Okay, and when is that possible? When both of them are either positive or both of them are negative, right? So we have two conditions, that is both of them are positive and both of them are negative, the numerator and the denominator. So let's try the condition when the numerator and the denominator, both of them are positive. So if we check x minus 3, it can be greater or equals to 0, right? Because it's in the numerator, so I can put an equal sign under this greater than sign. So this tells me x is greater or equals to 3. And at the same time, the denominator has to be positive too. So this is x plus 2 is greater than 0. So this tells me x is greater than minus 2, right? So we have two conditions like this. X is greater than minus 2 and x is greater than or equals to 3. However, now if you just stick to this condition, x is greater than minus 2, what you get, let's say you are taking x equals to negative 1, right? And you put that into the fraction that is minus 1, minus 3, and you have minus 1 plus 2, which is equals to minus 4 divided by 1. So as you can see, if you just stick to one of these conditions, things will go wrong. So the thing to do over here is to see which of the condition is the strongest. You see, whenever you take a number x and that is greater or equals to positive 3, that number x is automatically greater than -2. So among these two conditions, this is the stronger one. So this is my stronger condition. So from considering the fact that both of this numerator and the denominator has to be positive, we get a conclusion that x is greater or equals to 3. Okay, and now we do the same for the negative case when we have the numerator and the denominator as negative. So this time you will have x minus 3 greater or equals to, I mean, sorry, less or equals to 0, which tells me x is less than 3 or less than 3, and x plus 2 is less than 0. This gives me x is less than -2. Same story goes over here. Among both of these conditions, this is the strongest one, because if a number is less than -2, right? Since I can stick with this one, this will be my stronger condition over here. So I just want to stick to the stronger conditions. And I demonstrated here why things go wrong a few seconds ago. So now we are done. All we know is that x has to be greater or equals to 3 and x has to be less than 2. However, x will not be equals to -2. So if we draw a number line, let's say this is 0, somewhere over here is -2, somewhere over here is +2, 3, -3. So first of all, x is not equals to -2. So we just, you can just give it a cross mark like this. This is not equals to -2. However, x can be less than -2, and it goes on and on forever, right? And okay, let me use another color for showing you this is not equals to -2. So this red means x is not equals to -2. And the other condition tells me that x is greater or equals to 3. Yes, so this is 3 and this is greater or equals to 3. This is the stronger condition, right? And it goes on both ways. So what we have for the domain is x belongs to R such that the domain is something that runs from -infinity, which is not included. That's why I put a parenthesis over here, to -2, union 3 is included. So I'll put third brace, and to positive infinity. And you can just write x is not equals to -2. This is your domain for this function. Okay. And if you want to solve for the range, we can follow the steps that we showed in the previous video. But this time, the only thing that you have to do is to just square it, because you can write f of x as y, and then you can just square it. So if I write it like this, y equals to x minus 2 divided by, what was it? Sorry, x minus 3 divided by x plus 2. Did I use x plus 2? Yeah, sometimes I make mistakes about these things. So this is y squared x plus 2 is equals to x plus 3. I want to solve for x, so y squared minus 1 x equals to 2y squared, 3 minus 2y squared, and then you can say x is equals to 3 minus 2y squared, and you have y squared is equals to -1. As you can see, this time you don't get any square roots in the fraction, so you can just demand y squared minus 1, which is not equals to 0. That gives you y is not equals to plus minus 1. So apart from plus minus 1, all the real numbers are the range of this function. All right. Now, any fraction of this kind that is, sorry, okay, yeah. So any fraction of this kind can be solved like this, under a square root that has this linear format of ax plus b divided by cx plus d. So now what I was saying is that if you have any sort of a fraction like this, ax plus b divided by cx plus d, where a, b, c, d are real numbers, you can solve them by using the method that I just discussed over here. The rules will be the same. Obviously, you will have some A, B, C, D where A will be greater than D, B will be greater than C, or C will be greater than D, and so on. But the general rule of thumb is the same thing. All right, so now let's take another example. And I think this is one of my favorites. This is x plus 2, and let's say this is x minus 3. And we want to find the domain of this function. Again, the job is pretty similar, where we want to have positive quantity under the square root sign. So we demand both of this are positive separately, or both of them are negative separately, right? So let's consider the case where both of them are positive. So this is x plus 2. And obviously this can go to 0 because this is just a square root, so you can have 0, that's fine. So either this is 0 or greater than 0, and x minus 3 is 0 or greater than 0, right? This gives you x is greater or equals to negative 2 and x is greater or equals to positive 3. Again, if you take x is greater or equals to positive 3, both of them are positive always. Because you can just take any number that is greater than negative 2. Let's say you take negative 1, you can see x minus 3 minus 4. So if you take negative 1, x minus 3 becomes negative, right? But if you take x as something greater than positive 3, let's say 4, you see both of them are positive. So this is the stronger condition over here. And there is a reason I call them stronger condition, because if this is satisfied, this condition over here, the weaker one, x is greater or equals to negative 2, gets satisfied automatically. So that's why I call them stronger conditions. Now, this is one condition, we got them, we're very happy about it. Now what we can do, we can demand that both of them are 0 or less than 0, right? And as you can see, this is just x is equal or less than negative 2, or x is equal or less than 3. However, if you take x to be something that is equal or less than negative 2, this condition where x is equal or less than 3 gets satisfied automatically. So in this case, x is equal less than 2 is the stronger condition, because if you take anything less than negative 2, both x plus 2 and x minus 3 will yield a negative number. So if you multiply two negative numbers, you get a positive number, all right? So we have our answer. And our answer is x is either equal less than 2, equal less than 2, or x is greater than or equals to 3, right? And if you want to write it formally, you can write x belongs to R such that x is equal less than 2. You know, you can write it like this, or you can write in the interval notation, that is minus infinity to 2. 2 is getting included, so we're gonna put a third brace, union 3 to infinity. And in the number line, you can just show it like this. This is 0. Let's say this is, sorry, it should be negative 2. Negative 2, 3. So this is 3. This is included and goes like this over here. Negative 2 is included and goes to the left like this. So this is how you find domains of this sort of complicated functions. And sometimes you can even have, so this might be a food for thought for people who are seeing this for the first time. You can also go ahead and try with something like this: x plus 1, x plus 3, x minus 1. In this case, you have three small steps. I don't know what to call them, like three first order polynomials, okay? So you can just, play around with it. And similarly, you will apply the same conditions. That is, whatever the thing that is sitting under the square root has to be positive. So either two of them are positive and the other guy is positive, so all of them are positive. That's one case. Or two of them is negative and the other one is positive. That's another case, and so on and so forth. You can just play around with it. So let me know. This is something I want to left out for the audience, but let me know if you want to try it or you want me to actually post a video or a short to actually show you how to solve this sort of things. But the general algorithm is the same. And what I before I finish, I want to give a brief remark is that, for let's say you want to find the range. Finding the range is not always really easy, like how you do with the domain, because if I give you a cubic polynomial, let's say you have some cubic polynomial here, you want to find the range. Now, solving for this cubic polynomial will be hard. And if you go more order, let's say I give you some x over 10, like that's a nightmare. That's a living nightmare right there. So we can play around with the domains. However, finding the range is not always this easy or this systematical. But yeah, for simpler cases, we can do that. And we'll just need the simpler cases for our study in calculus. With that saying in mind, I think these are the two examples that I wanted to cover because I think that covers almost everything that I really wanted to talk about. So this will be it, and thank you again for watching and supporting us. We are almost our way to 300 subscribers. So if you do enjoy our content, do consider supporting, do consider letting your friends know. If they can see it, they can give us some feedback, or do you want to give us some feedback how we can do better? And yeah, keep supporting the channel. Thank you.